So upon completion of the lesson, you'll be able to follow along with the network configuration content in this module, and we're also going to determine the networking configuration objectives that are on the Linux Plus exam. So what will you take away from the module? Well, you're going to understand how Linux handles networking, and this knowledge is necessary, right? Because we need to communicate between servers. We don't want to just have one server alone. That's not super useful for us. And this body of knowledge is universal. You're going to learn networking here in Linux, and then you can take that anywhere. This information can be used to troubleshoot and understand networking, but we're also going to talk about routing and monitoring networks. And knowing how to manage, monitor, and troubleshoot network connections is foundational, and it's a force multiplier. I can't tell you how many times in my career I've had to troubleshoot networking issues, and particularly routing issues. So it's definitely something that is very, very good to understand and understand well, even just beyond the exam. So in this module, we're going to discuss hostname configuration. We're going to learn how to create and modify network connections. We're going to talk about how name resolution works in Linux. We're also going to learn how to perform network monitoring, manage network connections, and we're going to talk about network bridging, routing, and bonding. And then finally, at the end, we're going to touch on network security. So upon completion of today's lesson, you'll be able to determine where the host name is stored in Linux, both in CentOS and Ubuntu, and we're going to use commands to modify that system host name. So let's go ahead and get started with some demo time. All right, and in today's lesson and in today's demo, we're going to get started in Ubuntu. Now, in Ubuntu, the host name is actually just stored in etc hosts, and we can use our concatenate cat command to just print the output of etc hosts right here to our screen. What's called standard out. Okay, and what we're going to see in here is that the line is Ubuntu 20 right here, with the IP address 127.0.1.1. Now, for those of us who are coming from the Network Plus course, 127.0.0.1 may look familiar. That's the local host address, this loopback address. But 127.0.1.1 is a little weird. Well, that's a quirk from Ubuntu systems. And what it is it's an actual IP address that is associated just locally with the system for a system that doesn't have a static IP address. It's getting a dynamic IP address on this virtual machine from DHCP, which we'll also talk about later. And that's why you see that extra line entry here in etc hosts. But just for our purposes, just know that etc host is where you find the host name, and the host name for this system is Ubuntu 20. And I also have an entry in here for CentOS, our CentOS system. That's just a nice workaround so that I don't have to remember the IP address when I bounce back and forth between the machines later. Now, if you wanted to change the host name on this system, you can do so in a couple of ways. The first way you can do that is by elevating your privileges and then running the command hostname and passing in a new hostname for the system. So for our sake, let's change this from Ubuntu 20 to just Ubuntu and hit enter. And now if we exec a new bash shell, if we instantiate a new shell just by running bash, we'll say that the hostname has changed from Ubuntu 20 to just Ubuntu. But not so fast. This is just a temporary change. If we were to do cat etc hosts, we see that the host name in here is still Ubuntu 20. So if we wanted to have that be persistent, we would need to modify etc hosts in order to change this host name. But that's pretty much what you need to know for host names in Ubuntu. Let's move over to our CentOS system. Now, we're looking at our CentOS system here, and when you're talking about CentOS, you have to understand that the host name is nowadays stored in the etc hostname file. So just like we did with Ubuntu, we can go ahead and concatenate that file, cat it out to print it out here to the screen. And we can see that our host name is CentOS, and that matches the host name that we see here in our shell prompt, right? CentOS 8. And if we wanted to change it, we could do it the same way we did in Ubuntu. We can temporarily change it using the hostname command. So we can modify the host name from CentOS 8 to, let's say, CentOS. Okay, and then I need to provide my password so I can elevate my privileges. And now I can do a new bash shell, and we see that the host name has changed to CentOS. But just like we saw before, this isn't a persistent change. So if I go back in here, I'm going to see that the host name is set to CentOS temporarily. But if I hit etc hosts, print it out again, etc host name rather, what I'm going to find is that it is still CentOS 8. So let's maximize a window here again. And if we wanted to change this to match this, in other words, if we wanted the host name to be set persistently to CentOS instead of CentOS 8, we can use another really nice command that was released with RHEL 7, Red Hat Enterprise Linux 7, and that command is called hostname CTL. Now, just like we saw with hostname, we need to run this with elevated privileges. So we'll run sudo hostname CTL, and then we can use the command set hostname, and we can type in the new hostname we want to give the system. So we can change it from CentOS 8 to just CentOS, and hit enter and type in the password again. All right, and now if I cat etc host or etc hostname, we see that the hostname has permanently changed to CentOS. If we reboot the system, it will remain with this hostname. Now, keep in mind that this is the case for newer RPM-based distributions. The hostname lives in etc hostname. In Ubuntu distributions, the hostname lives in etc host. You may see questions on the exam about etc sysconfig network, and that's where hostnames were stored in older RPM-based distributions of Linux, but that's no longer the case today. Demo time. Okay, and in today's demo, we're over here in our CentOS system. Let's go ahead and navigate to that directory I'd mentioned. We got to go to cd etc sysconfig network scripts. All right, and then if we do an ls-al in this directory, we're going to see all of the interface files, the network connection files on this system. Now, on this particular VM, I only have a single interface file for this ifconfig enp0s3. Now that's the interface, the network connection that we're using for this system. It's a little bit weird, enp0s3, what does that mean? Well, that is actually gotten from something called predictable interface naming that takes into account the way that the system comes up, the settings in the BIOS, the order that the PCI bus boots in. A lot of these things we'll cover later, but if you want to know a little bit more about why that has such a wacky interface name, take a look at predictable interface naming. Go ahead and Google that, and you'll know all you need to know. But let's go ahead and take a look in this file. So if we do a less on ifcfg enp0s3, hit enter here, what we're going to see is all of the configuration that is specific to this interface. Now, it's not super interesting on this system, and that's because I only have DHCP. I'm just getting an IP address over DHCP. So all we really see in here is that the type is Ethernet. We're running the boot protocol DHCP. If we were using a static IP addressing, we would see some other settings in this file. So for instance, our boot protocol, instead of saying DHCP, it would say static. If we were running a static system, we would have an IP address line, IPADDR. We would also see a netmask line. We would see a gateway to specify the default gateway that the system is using with the static IP address that it has. And then finally, we would also definitely see a broadcast, pardon my typing. We would see a broadcast line in that file that would indicate the broadcast network that the interface is on. But that's pretty much it for the network scripts directory and the network configuration files that we find in the network directory. Well, that's pretty much it for etc sysconfig network scripts and the interface files that we see in that directory. Now let's move over and take a look at the DH client. Now, the DH client on this system is used for DHCP. It's used to configure DHCP on this system to connect and talk to a DHCP server. So the DH client file is found in etc DHCP DH client. And actually, we're going to try and just do a less on this if we can. We'll see if it allows us to. We might actually need to become sudo. And we do. We need to elevate our privileges in order to view this file. So let's just do a sudo edit. And what I'll do here is I'll type in my user password to elevate my privileges in order to read that file. Okay, in CentOS, the only configuration is a single send command. And we can see that down here at the very bottom. Send DHCP client identifier equals hardware. Now what this specifies is that the DHCP client is going to send the MAC address, the hardware address of the interface to the DHCP server. And in today's lesson, as I said, we're going to take a look at Ubuntu. Now let's go ahead and open our terminal window here, and we're going to navigate into the directory that is called etc netplan. Now the etc netplan directory Now, the Etsy netplan directory is going to contain our configuration files that we would use to set up the network configurations, all the different interfaces on our system. It's actually just a YAML file. YAML is a file syntax that is used by Ansible to do configuration. We'll touch on Ansible much later at the end of the course. But for right now, let's just go ahead and take a look at this file. We're going to go ahead and do a less on this file, and we can see that this is just using Network Manager. So this isn't really super helpful. We'll take a look at Network Manager in a minute, but generally what you'd find in this file would be this syntax. You would have a network line, and then you have things indented. That's how YAML does things. And then you would have individual lines to configure things on the network. So for instance, you might have an interface name for the system. You might also have the DHCP. DHCP4, this would be set to yes or no. Yes for using DHCP, no if we're using a static address. If we were using a static address, we would see a line that would say addresses in this file. And then finally, we would also see a line like gateway 4 in this file that would indicate the default gateway that would be used for a static network on this system. However, as I said, we're not using NetPlan on this system. No, we're using something called Network Manager. So Network Manager has a different configuration location, and you can go into Etsy Network Manager System Connections. Now, if we do an ls in this directory, we're going to see wired connection 1 NM connection. Now, I can probably try and do an ls and just hit enter here, and what we're going to see is that we have these weird backslashes. And the reason that we're doing this is because Linux is escaping the space. It doesn't really know what to do with it. So unless it escapes it by putting a backslash before every space, it will know how to interpret the file and open it correctly. So that's why you see that. Another way we could do this, so that we wouldn't see these weird backslashes, is if we actually just copy this line, including these single quotes, and then we could do a less on it that way. And actually, in this case, we can't even view it. Not like we could with NetPlan. We actually need to get elevated privileges. So we're going to run sudo edit so that we can edit the file. We're not actually going to edit it. We're just going to view it. But we use sudo edit to get into it. I'll type in my user password to elevate my privileges and then hit enter. And now we can see the contents of this file. And again, here, this is not a lot of information, just as we saw in the previous lesson with the network scripts directory and the ifconfig enp0s3. We see sort of the same thing here. We've got an ID that says this is a wired connection and it's type Ethernet, and we also see the interface name, and that's basically it. And the reason for this is that just like we saw in CentOS on Ubuntu, we're just running DHCP. So we'll see some information in here, but certainly not as much information as we would have seen in this file. If we were running static addressing, you would see additional entry lines here that would have a value or a key on the right-hand side and a value on a key on the left-hand side and a value on the right-hand side separated by an equal sign. So for instance, you see address equals and then the IP address, or gateway equals and then the gateway, so on and so forth. But that's pretty much what we need to know for the connection files inside of here. Let's quit out of that file with escape:quit. And what we're going to do now is we're going to take a look at the DH client directory. So if we go to Etsy DHCP, DH client, and what we're going to want to do is let's just do an ls in this directory. And what we can see in this directory is all of these DH client files. And that's because DHCP in Ubuntu is a lot more complex than it is in CentOS. And in fact, let's do another sudo edit just in case we have to get elevated privileges as well. Now let's take a look at the dhclient.conf file. And now what we can see in this file is that by comparison to CentOS, it's very complicated, very busy. Remember, in CentOS, there's only one line in this whole file: send DHCP client identifier equals hardware. Whereas here, we're sending the host name. We're going to send the host name over to the DHCP client to get the information, but we're also going to ask for that to be specified using the RFC 3442 classic static routes. And we're going to request a whole bunch of information back from the DHCP server. And you can see this on the request line. This is all the information that we're trying to get back from the DHCP server. So just remember that the dhclient.conf file in Ubuntu is significantly more complex. It requests a significant amount of information more from the DHCP server than what you would see in the CentOS system. So routing is simply sending data from one point to another, right? We're sending data from one point to another through a gateway. The gateway is an important thing to consider here because that's what's connecting two different networks together, okay? Routing can be very straightforward, but there are a lot of different ways to work with routing in Linux, and that's what makes it complicated. At left, there are 3 different routing commands. all of them display routing information, right? So this is where it starts to get complicated. Route and netstat-r. Route and netstat-r display a routing table. Route-n displays the destination numerically. So in other words, it's not going to convert the IPs into host names. It's just going to display the IP addresses. Netstat-r displays a different column info than the other ones. And then finally, IP route shows more of a collapsed output of routing. Now, what we can generally see is all of these have a destination column, or at least the first three. And that shows the destination network or host. And the gateway column shows the gateway that is used by the network or host to get connected to something else, to go through to hot to the next network. The flags column that we see in the first three of these commands can indicate a few things, and it depends on the flag. U means up, the host is up, right? G means use gateway. And H, we don't really see here, but H indicates that the target we're trying to get to is the host itself. The metric column shows the distance to the target in hops. So how many hops, how many connection points do you need to go through to get to the target? And the interface column specifies the interface that will handle traffic for this route. In this case, on this system, it was the Ubuntu system. I took screenshots from my own system. You can see the interface is all the same. But if we had a network that was connected to multiple different, if we had a system rather that was connected to multiple different networks, we might have different interfaces for different networks on different networks, and you would see the different interfaces here to route things between different networks depending upon the interface that it's going out of. Now, the route command in Linux is specifically built for routing. If you use it with no options, it's just going to give you a routing table, and you can add or delete a route using route add or route delete. So route add, the target you want to go to, the gateway you're going to use, and the IP address, and then the same thing for route delete. Route delete, target, gateway, IP address. However, the changes with the route command are not persistent. Now, you can also do network routing using the IP command. Again, the IP command we talked about previously, very versatile. You'll use it a lot. IP command can be used, and we can just use IP route by itself to give us kind of a collapsed routing table. You can add or delete a route by using IP route add, target, via gateway, device interface. And then we can delete one even more simply. We can just do IP route delete and specify the target. But just as we saw previously with this, the changes with using the IP command or the route command are not persistent. This is just something that you could do if you thought that you had a route issue. You would just go ahead and maybe set up a route here to see if that would fix your issue. And then if it did, you could go ahead and create it persistently in another place. And the place to do that in CentOS is to do a gateway line in the interface file. So you can enter into etc sysconfig network scripts if config interface. So in our case, right, EMP0S3, we can enter into that a gateway line that indicates the gateway we're going to go out for the network, for that specific network on that interface. Or we can also create a route file. So we can do etc sysconfig network scripts route-interface and create a route file that contains the routes that are going to use that interface to get out. Now, if you're in Ubuntu, you have two options for persistence as well. One is to enter a route section into the netplan YAML config. And we remember netplan is configured in etc netplan, the name of the interface or the name of the connection .yaml. Or you can also modify the interface using nmcli or nmtui, those two commands we covered in that previous slide.